Hey guys, so we are going to talk about best practices for running database on Kubernetes. First important questions. How many of you think that running database on Kubernetes is a good idea? Okay, couple of brave hands. More? Anybody else? Okay, look at that. Oh, you are such a conservative bunch. You know, if I go to San Francisco instead of Washington, that is a slightly different proportion. Okay, so if you look at the second question, so if you guys, there's like a few hands I saw here and there, running database in Kubernetes, what database are those? MySQL, anyone? Postgres? Okay. Valky, Redis? Anything else? Just, shout out so I can hear. Okay, Cassandra. Okay. Cool. Well, in this talk, my point would be twofold. One is to try to convince you, the rest of you Luddites, is that a word? About running databases on Kubernetes is a decent idea, and then also show some best practices about how you can do that. Now, first, let's look at what is our conventional way to run a database in the cloud, right, and why. Now, if you go to the history of the cloud computing, this is a slide from AWS, actually, presentation, probably now, 15 years old by now, right? As you can see the old logo, and so on and so forth. And they used to advertise cloud or something and say, hey, this is awesome. It's kind of commodity as electricity. It doesn't make sense for us to produce our own electricity at home, at least most of the time. Same thing with cloud. And then, of course, it transitioned from that commodity to this highly differentiated and a proprietary cloud, right, where Amazon, Google, Azure, doesn't matter. They want you to run those kind of a highly differentiated proprietary features in a cloud so you are locked in. And a databases are a fantastic way of doing that. So wherever you look at those like a cloud, best architecture as cloud vendors would advise you, that would be, oh, please run the most proprietary database in our cloud. Don't run them on Kubernetes. Don't roll out your own. Run something like DynamoDB, maybe Amazon Aurora, Spanner, right? The most proprietary shit, the better. So that is, of course, very good for cloud vendors, right? And for you, if you work for cloud vendors, but maybe not so much if you pay cloud vendors. Well, anyway, I'm not sure if I ever get invited here again, but that's beside the point. Well, if you look at Kubernetes, of course, Kubernetes was designed as something for stateless applications initially, right? And of course, the databases is opposite of stateless, right? That's where the state's supposed to be, so it kind of wasn't a good place on Kubernetes at some point. Now, if you think about that, of course, Kubernetes was evolving to support data-intensive applications for, I think, last decade. For example, we see this data on Kubernetes community, pretty active, one of those, data on Kubernetes. Focused community, which did a lot of strides and I think enable a lot of data-intensive workloads on Kubernetes. And here is, I grabbed the slides from one of a recent presentation, right? If they pull their people, which of course of kind of little bit, selection bias, it is much more hands in terms of how many of them are, running Kubernetes workloads, right? And you can see significant amount running stateful workloads such as databases in productions. And I think what is also interesting, if you go kind of to their a lot of databases solutions which are deployed in the cloud, you also find what many of them actually use the Kubernetes in the background, right? Of course, they typically have some sort of engineering team, and Kubernetes is set up appropriately. But what that tells me, and probably can tell you, is what it is kind of feasible, right? Because we don't hear those kind of reports. The cloud vendor X lost all their data because they happened to run their database on Kubernetes, right? And all their customers are angry and they kind of declared bankruptcy. And then also it can be done efficient enough, right? Because when you're providing database service to your customers, right, you want that to be reasonably efficient, or that becomes too expensive for you. And indeed, if you configure Kubernetes correctly, you can get relatively low overhead when it comes to databases. OK. With that, let's move and talk at some of our best practices when it comes to Kubernetes, right? And a lot of those are going to be pretty basic, obvious even. But I think that is something which is quite important. Like as in many things in life, it's kind of getting those kind of relatively few basic things right is where the most value comes, right? And so many of us, right, just find a hard time doing that. That happens, with eating or exercises, and that also comes, to your database configuration on Kubernetes. OK. Here we go. The first one, there are a number of ways you can deploy database on Kubernetes, right? You can actually drop your container on Kubernetes, maybe just get some basic Helm chart. What I would suggest you, if you are running database on Kubernetes, then use the operators which are provided to many popular databases. These are going to really take care a lot of those kind of day two automation beyond just provisioning the database. And that is what is an interesting and kind of amazing things about the databases. They spend most time in this sort of like a day two, right? And we cannot deal with them as if stateless application. Hey, if something doesn't work, we doesn't like something, let's shut it in the head and redeploy again. With databases, you cannot do that because you always need to care about the data. Second one is you absolutely want to make sure you set up with high availability, right? Because of the nature of Kubernetes, right? It's not the same as your kind of bare metal where you can have something like, well, I have a server which I didn't reboot in whatever number of years, right? And it's kind of available on itself, right? You want to make sure have some sort of multi-nodes, clustering, replication, so on and so forth. Then you also need to ensure you are actually keeping their data persistent, right? We have seen different deployment patterns here, where again, you want to understand that. Some people use their persistent local persistent volumes, right? Like SSD can be very inexpensive, very high performance, but of course it's not redundant when it's on if a node goes down. So if you're using that, you need to make sure there is some replica going on, as well as their fast remote storage also works. You also want to keep the data per pod small, right? I mean, small is relative, but you're saying, oh, you know what, I am having this, 50 terabytes, massive bare metal servers, right, with, a couple of terabytes of RAM and whatever, and I'm looking to move that to a single pod on Kubernetes. You are likely to have some problems, right? Usually we operate the pods on the smaller size if some sort of sharding involved if needed, and so on and so forth. At the same time, you often would want to make sure what this Kubernetes deployment where you deploy your database is sized to provide you ability to deploy larger pods with large amount of memory. I've seen people kind of deploy in relatively small VMs on the Kubernetes, and they say, well, you know what, if I need to have, you know, half a terabyte, right, or something of a cache for a database, I just cannot do that because I cannot get such large amount of memory in my Kubernetes cluster. Well, if that is something what you know, the database workload requires, you need to make sure you have that. You also want to make sure you configure resource and limit requests, right? That is, I think, is very important, in particular in production, because otherwise you see database being deployed in the cluster. It's kind of idle. It gets a lot of resources, gets certain performance, but then you put it in production based on those assumptions about performance, and then because of a noisy neighbors, it kind of gets squeezed, have a different performance profile, and people are kind of very unhappy, right? Obviously, Kubernetes default is kind of different compared to a VM where you sort of often get a very fixed resource allocation. You also want to make sure what you are setting proper anti-affinity rules. And many Kubernetes operators actually have a sensitive defaults for you here, right? But you obviously want to avoid situations saying, hey, you know what, I deployed multiple database nodes, it's high availability, but they all happen to be on the same physical server. Not a good idea, right? Probably not a good idea if they're even on the same rack, right, or something like that. Number 8, you want, of course, to tune your database. That's, well, Kubernetes doesn't change anything in this case. It doesn't automatically solve this kind of problem, right? So all the database parameters need to be changed, as well as giving a good care to your queries, to your index is the same way important. And I mentioned that as I think there's often kind of so much desire saying, hey, you know what? Maybe we can just get away with people who, understand the databases, just have a developers, use a database and it will automatically take care of itself. Well, it doesn't happen, at least not quite yet. In this case, I'll mention one of the open source tools. We have at Percona for that called Percona Monitor and Management. So you can check it out. Then we also want to understand how to scale. Right, some databases can be scaled out, right, with sharding. Some not. Some even cannot use multiple, CPU cores to serve a single query, right? Like Postgres has parallel query features. MySQL doesn't. You need to understand that property. Another Kubernetes specific thing is you want to control eviction with a pod priority. Within the databases, a lot of them, can handle, right? If you just, kill it, restart the database, it will do kind of crash recovery, and everything will be good. But it takes significant time and performance hits. Often crash recovery takes time, and then database typically needs to warm up by kind of reading a lot of data in the cache before it reaches their best performance. So you don't want that happening unless you need that. Another one is do not expose your database externally unless you really have to. So many security issues happen from accidental exposure, right, or exposure, and then people forget it in some way. So that is, I think, is one of the key security practices you want to hear. You also want, of course, to make sure you enable encryption. That both applies for data at rest, which is supported by many databases those days, and also TLS for connections over insecure networks. Again, these have been out for so long time, and they're quite well optimized those days, so it's not going to be super, like a significant overhead. And then the other last thing in terms of security for me to cover is make sure to use Kubernetes secrets. Again, many Kubernetes operators have integrations between Kubernetes secrets and native database users, which you can use, and that is much better approach than just saying, hey, we are going to hard code credentials. Well, as if everything, database doesn't change anything here. Then there are backups, right? Of course, I mentioned you want to have ability. You have some clustering and replication, but of course, that doesn't save you if you accidentally, and somebody else, for example, drops a table or runs some bad updates which corrupts your data. You want to have backups. Again, the nice things here of operators, most operators makes it kind of very easily, right? You can just define a backup policy and we'll make it happen for you. You don't have to manage that externally. Now, something else I would highlight here is this next generation databases, besides the conventional one, which are designed for a cloud. You want check it out. I'll speed up a bit as I just have 3 minutes left. Another best practice would be to look at the CPU choices, right? You can see, I think, a lot of cloud vendors now make their specifically ARM-based CPUs, very affordable, and for many databases, they actually perform quite well. You all have a choice of picking a Kubernetes deployment mode. We find both people using the managed Kubernetes solutions by those data vendors, as well as running their own, with different benefits on backdrop, but that decisions you can take. And of course, you want to make sure you monitor utilization. One thing with Kubernetes, I think, especially if you deploy it in a way that new nodes can be automatically provisions, right? You can incur surprising costs, which you may not see in a different deployment modes. Okay, now let me also mention a couple of tools which may be relevant in this case. Now, from our standpoint at Percona, we provide the open source operators for MySQL, PostgreSQL, and Mongo. These are not the only one at the market these days, but we think ours are pretty mature, good, and what is important, open source. Now, some of you, especially if you, or maybe some people on your team say, well, you know what, it's all good, you have an operator, but UX on that is not exactly the same as in those tools like Amazon, RDS, Aurora, and such. And we at Percona also been recognizing that, and we've been also working on another open source project called Percona Everest, which allows you to get RDS-like GUI, right, for bringing and managing databases with Kubernetes backend, right? So if that is something which may be interesting for some of your developers, you can check it out. And the last tool I wanted to mention is a tool called the Karoot. It's similar to what the guys at Ground Cover are doing, but that's for open source solution which uses eBPF and a bunch of other magic, which allows you to understand what is going on in your environment, what is actually going on, what then compared to what you believe is going on. We find it's often is different, right? And that's helps with a lot of stuff I mentioned, like understanding, for example, costs, what service talking to what traffic you have between availability zones, right, for example, which is very important for databases because you often want that for availability, but then also amount of stuff which goes on out there can be surprising. And with that, it's all I have. Thank you.